Hello Math Analysis students. In this video we are going to work through the problems on the Unit 10 Trig Formulas Review homework. Now there are actually 20 questions on the homework. We are only going to go through the first 16 because that's all we have covered this year. Okay, first let's look at our formulas. You do not have to memorize these formulas. This will be an open notes test, and there is also a formula sheet available for you to use. You don't have to memorize them, but you do have to know how to use these formulas. If you use the formula sheet that I have in class, it's a yellow laminated sheet, there is also a set of half-angle identities. We have not covered that material, so we will not be using any of the half-angle identities formulas. We will only be using the sum and difference formulas and the double angle identities. We have worked with all of those formulas so far. Remember that you need to be able to recognize what the plus or minus means and the minus or plus sign as representing the opposite operation. And remember down here for this, for the cosine of 2u, it's not actually this full line. There's 3 formulas that you could choose for this. So helpful to be able to know how to use them before the test. Okay, so our first few problems here are about simplifying. And so I have included, I think I've included on every slide, the formulas that we'll be using so that we can refer back to them every time. All right, so problem number 1, we've got cosine squared 50 minus sine squared 50. So we've got this 50 right here, which is in both of them. So that is going to be our u. That would be in one of these formulas. We just need to figure out which one does it look like. It looks like cosine squared minus sine squared. So I want to just say that cosine squared minus sine squared looks like this formula right here. Cosine squared u minus sine squared u. So that's equivalent to cosine of 2u. So that means that this formula is the equivalent of, if our u is 50, then this would be equal to the cosine of 2u, which is 2 times 50, which would be the cosine of 100 degrees. Since 100 is not a unit circle value, then we'll leave it at that. We don't need to go any further. For our next formula, we are looking at, we have sine 75 cosine 15 plus cosine 75 sine 15. So we've got 2 numbers here, so the 75 and the 15. 75 will be like our u, and 15 will be our v. Okay, both of these, u, v. And we have here this formula, which is sine times cosine plus cosine times sine. And we look up here to see which one does that look like. And sine times cosine plus cosine times sine looks a lot like this one right up here, which means this is a formula for the sum of sines. So this would be sine of u plus v. So that would be sine of our u is 75. And our v is 15, which would give us sine of 90 degrees. Now, since 90 degrees is one of our unit circle values, go ahead and evaluate that. The sine of 90 degrees is 1, so our most simplified answer here is the number 1. For problem number 3, we have 2 tangent 55 over 1 minus tangent squared 55. Hopefully, it's obvious that this is going to be something to do with the tangent formula. So look at both of them right here. We've got the tangent formula here for the sum or difference, and here is a double angle. This looks like 2 tangent of 55 over 1 minus tangent squared 55, with 55 being our u. This 2 tangent u over 1 minus tangent squared u is clearly looking like this one right here, so it will be our tangent of 2u. Tangent of 2 times our u value is 55. 2 times 55, that is going to be the tangent of 110 degrees. Since 110 is not a unit circle value, then we leave it there. That's as far as we have to go. Okay, for our next problem, we have cosine 4x cosine 2x plus sine 4x sine 2x. So we've got a u value of 4x and a v value of 2x. And we have a formula here that looks like we've got cosine times cosine plus sine times sine. So cosine, cosine plus sine, sine. That looks like this right here, our formula for our cosine. Notice here that because of we have the minus or plus sign, it's going to be the opposite sign. So if we have a plus here, that means that we are actually using a difference formula. So this is going to be the cosine of 4x minus 2x, which will be the cosine of 2x. Clearly not a unit circle value because we don't know what x is. And for our lesson right here in this section, number 5, we've got cosine cosine plus sine sine, which again looks a lot like what we just had right here. We've got a u value of 15, a v value of 9, and cosine cosine plus sine sine looks like this formula right here for our cosine. And again, since we have a plus, then we're talking about a difference. This is the cosine of, the cosine of 15 minus 9, and 15 minus 9 is 6, so this is the cosine of 6 degrees. And 6 degrees is obviously not a unit circle value, so that is as far as we need to go with that. Okay, for number 6, we have the tangent of 5x minus tangent x over 1 plus tangent 5x. Tangent x, we want to write it as a single trig function. So we have two values right here. We've got a 5x, which is a u value, and a plain old 1x, which is our v value. And so we're looking at tangent u minus tangent v over 1 plus tangent u tangent v. That looks like our formulas here for tangent. And since on top we have the plus or minus, we're talking about the same sign as whatever is in our problem. So this looks like it simplifies to be the tangent of, let's see, 5x minus x, which is going to be 4x. So we would rewrite this as the tangent of 4x. Okay, well, let's move on. Okay, let's find the exact value of the cosine of 135 minus 30. Well, if we were to just subtract that, that's at 105. 105 is not one of our unit circle values, so we wouldn't be able to simply evaluate that. I generally think in terms of radian families, so I want to recognize that 135, that is 3 pi over 4, and 30 is pi over 6. Now, if I'm finding the cosine, then that means I want to use the cosine formula, which is right here. And this one, again, has we've got the plus or minus over here and minus or plus here, meaning it's going to be the opposite sign. So if we're doing the cosine of 135 minus 30, that's going to be equal to the cosine of 135 times the cosine of 30 plus the sine of 135 times the sine of 30. That's just the part where we expand. And now we evaluate. The cosine of 135, that's in the second quadrant, so the cosine is negative root 2 over 2. And the cosine of 30, which is pi over 6, the cosine is root 3 over 2. Plus the sine of 135 is positive root 2 over 2, and the sine of 30 is 1/2. So we've expanded, and then we've used this unit circle, and now we just do our algebra. Negative root 2 times root 3 is going to give us negative root 6, and our denominator is 4, plus root 2 times 1 is just root 2 over 4. So when we combine these together, because they have the same denominator, it's negative root 6 plus root 2 over 4. Or, if you preferred, you could write this as root 2 minus root 6 over 4, as long as we make sure that we have the positives and the negatives in the right place. All right, for number 8, we have given sine of alpha equals 3 over 5 in quadrant 1, and cosine beta equals negative 12 over 13 in quadrant 2. Find cosine of alpha plus beta. Okay, so we need to draw this. We have alpha is in quadrant 1 and beta is in quadrant 2, so I'm going to draw this over here. Pictures don't have to be great. But in quadrant 1, we have alpha here, and if the sine is 3/5, sine is opposite over hypotenuse. So that means that our opposite side is 3, the hypotenuse is 5. When we do Pythagorean theorem, then we're going to get that our missing value is 4. Cosine of beta is negative 12/13 in quadrant 2. So beta is, here's our angle beta, quadrant 2. The cosine is the adjacent over the hypotenuse. So our adjacent side is negative 12, which makes sense. Second quadrant, x is negative. And our hypotenuse is 13. And Pythagorean theorem will tell us that this missing value is 5. Now that is a positive 5 because in second quadrant x is negative and y is positive. Okay, so we've drawn our picture. Now we need to figure out which formula we want to use to expand. So we're doing cosine of alpha plus beta. So we're going to use our cosine formula right there. So this is going to be equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And again, minus here because the minus or plus sign means the opposite of whatever this was here. If we had a plus here, we're going to have a minus here. So since we have our pictures, now we just evaluate the cosine of alpha, which is adjacent over hypotenuse, that is 4/5, times the cosine of beta is negative 12/13, minus, okay, the sine of alpha is 3/5, over the sine of beta is 5/13. So now we just do the math. 4/5 times negative 12/13. So we're multiplying fractions. Just multiply across the top, multiply across the bottom. If we could simplify, we want to, but that doesn't. Minus, this is going to give us 15/65. We have the same denominator, so we keep that denominator and we combine our numerators. Negative 48 minus 15 is a negative 63, and our denominator is 65, and so that's our answer on problem number 8. Problem number 9, simplify cosine of 90 minus x. Once again, we are using our cosine formula right here. Okay, so that is going to be equal to the cosine of 90 times the cosine of x plus the sine of 90 times the sine of x. Because this is a minus or plus sign. If we have a minus here, then we're going to plus here. Now we evaluate the cosine of 90. The cosine of 90 is 0. So this is 0 times the cosine of x. 0 times anything is going to be 0. So this term is going to just go away. And the sine of 90 is 1 times the sine of x. So we have 0 plus 1 sine of x. It's just sine of x. And for number 10, write 2 sine 2 theta cosine 2 theta in terms of a single trig function. Okay, so a couple of ways we could look at this, and we could say about we could substitute something for sine 2 theta and cosine 2 theta. But actually, when we look at this, this is we could see this as our u value is 2 theta right here. And this would actually be, since they're both 2 theta, 2 sine u cosine u, which actually looks like this here. 2 sine u cosine u, if our u value is 2 theta, then that's equal to sine of 2u. So this is equal to sine of 2u, and our u is 2 theta, so 2 sine of 2 times 2 theta, which is the sine of 4 theta. And that's the front problems. I will make a separate video for the problems on the back.